So this lesson is entitled Quadratic Systems. Now, we've already dealt with solving linear systems, but now we're going to, since we know how to solve quadratics, we're going to bring quadratics into the mix as well. All right, so our goal today is very simply, I want to be able to solve quadratic systems algebraically. All right, so I really have no new techniques to teach you or anything. What I want to do, though, is just do a couple examples to kind of give you some guidance here. All right, so our first example, let's say that we have y equals x squared minus 3x minus 20. And we have, so that would create a parabola. And then we have a second equation here that says y is equal to negative x minus 5. Or I like to write negative 1x minus 5, which is the equation of a line. So what it meant to solve a system of equations in the past was we find the point of intersection. Now what we're going to have is what's called a quadratic linear system. The first equation tells me it's quadratic. Second equation tells me it's linear. When we have a quadratic linear, if you think about it, there's the potential that we could have two locations that a line passes through a parabola. That's what we're in search of. All right? So the technique that we're going to use here, though, is we're going to simply use the technique of substitution. I'm going to substitute what y is equal to into the other equation. All right? So that would give us negative x minus 5 equals x squared minus 3x minus 20. I'm going to move the negative 1x and the negative 5 over to the other side because I noticed that the equation is quadratic, so I want to set it equal to 0. So I'm going to rewrite this as x squared. If I add that 1x, that would leave me with minus 2x. If I add the 5, that would leave me with minus 15 equals 0. So now what I'm looking at is I have a quadratic to solve. How do I want to solve the quadratic? We've got our list of different methods, all right? One thing that I observe right away is this has a goal number of negative 15, a middle term of negative 2. Factors are 3 and negative 5. And I divide them both by a, which in this case is 1. That tells me that the factors would be x plus 3 and x minus 5. Set each factor equal to 0, and I get x is equal to negative 3 and positive 5. But all that this tells us is the x values. We know that what we're looking for is two specific locations in the coordinate plane. So then what I need to do next is take each of those x's and find what y corresponds to that x. Sorry, I had to get a drink there. All right, so very simply what I'm going to do is take negative 3. I know I'm trying to write the point negative 3 something. If I plug negative 3 into the second equation, I have y equals negative 1 times negative 3 minus 5, or there'll be 3 minus 5, which is negative 2. So I have the point negative 3, negative 2. That is one location that these two graphs intersect each other. Now I'm going to take the 5. I'm trying to write a point for that. All right, and I'm going to substitute that into the second equation. I have y equals negative 1 times 5, which is negative 5, minus 5, which would be negative 10. And now I have the two locations that these graphs will cross over each other. One is at negative 3, negative 2. One is at 5, negative 10. And if you were to graph these two equations, you'll see that those are the two exact locations that they intersect each other. All right? So let's take a look at a couple more examples of this, but pretty much it's going to be the same routine here, guys. This next example I thought I would throw at us involves what do you do if you have a negative x squared? All right, so I've got negative x squared minus 5x minus 1. And my second equation, that first one was quadratic. Second one, we'll just make it linear, x plus 2. All right, so again, I'm looking at a quadratic linear system. I'm anticipating 2 points of intersection. There could be one, there could be none. All right, remember, if they're none, then there is no solution because they don't cross over each other. All right, so I'm going to use substitution. I'm going to plug the x plus 2 in for y into the top equation. All right, so now I've got this equation that I need to solve. I notice that it's quadratic, but I also notice I have a negative a value. Well, all you got to do is simply make an adjustment. Move everything on the right side over to the left. Because remember, to solve a quadratic, we have to set it equal to 0. So I'm going to move the x squared over. I'm going to move the 5, which now gives me plus 6x. I'm going to move the 1, which gives me plus 3, and that equals 0. All right. I notice right away I'm not going to be able to factor this. There's no two numbers, multiply to give me 3, add to give me 6. No worries. I've got other techniques. I'm going to choose to complete the square because a is 1 and b is even. All right, so if I complete the square here, 6 divided by 2 is 3. 3 squared is 9. All right, I'm going to factor the left side to x plus 3 squared, and the right side is 6. Square root both sides, I get x plus 3 is equal to plus or minus the square root of 6. So x would be equal to negative 3 plus or minus the square root of 6. All right, these are the x values at the points of intersection. So now I need to find the corresponding y values. So let's write this first x down. I have negative 3 plus the square root of 6. All right. To find the corresponding y, sorry, I don't know why I closed that parenthesis up, but to find the corresponding y to that x, I'm going to substitute it into that second equation. Y equals negative 3 plus the square root of 6, and then plus 2 here. So remember, this negative 3 plus the square root of 6, I'm replacing this x with what we found x to be. All right, I'm going to clean this up a little bit, and that gives me negative 1 plus the square root of 6. I can't put them together because one's rational and one's irrational, so I know that that's my y value for that corresponding x value. All right, and then our second point will be negative 3 minus the square root of 6. Again, I'm going to substitute it in. So I have y equals negative 3 minus the square root of 6 plus 2, which would be negative 1 minus the square root of 6. And these are the two exact locations that these two graphs, one quadratic, one linear, that they will cross over each other. All right, let's try one more. So let's take it a little bit further, and let's say that we have these two equations. Y equals negative 3x squared minus x plus 2, and y equals x squared plus 2x plus 1. All right, in this particular situation, we have what's called a quadratic system. Here's the beauty. I, again, don't have to learn a new technique. I'm going to substitute this quadratic into the first equation in place of y. So that will leave me with x squared plus 2x plus 1 equals negative 3x squared minus x plus 2. As I look at this brand new equation, which is the two quadratics combined together, I notice that it's a quadratic. So now I go back to, how do I solve the quadratic? In order to figure that out, I know it has to equal 0. So I'm going to choose to move everything on the right over to the left so that I can deal with a positive a value. So this would be 4x squared. Let's see, add 1x plus 3x. Subtract 2 minus 1 equals 0. All right, I believe that this is factorable. I know that I have a goal number of 4 times -1 or -4, middle term of 3, which factors to -1 and 4. Don't forget to divide by 4. A is 4. So this will factor to 4x minus 1 and x plus 1. Set each factor equal to 0. I get x is equal to 1/4 and -1. All right. So I know that that my solutions have x's that are 1/4 and -1. All right. So I'm going to start with the 1/4. I'm going to choose to plug it into the second equation. So I have y equals 1/4 squared plus 2 times a fourth plus 1. All right, let's clean this up a little bit. This would be 1/16. Let's see, that would be 2 times a fourth. That's 1/2 plus 1. Now I'm going to rewrite this so that everything has the same denominator, common denominators. So this would be 1/16 plus 1/2 is really 8/16, and 1 is really 16/16. All right, so that tells me that y is equal to, let's see, 1 plus 8 is 9 plus 16. That would be 25 over 16. All right, I now know that I have the point 1/4 and 25/16. That's one of the points of intersection. The second point of intersection you find by substituting in the -1 that you found. So I have y equals -1 squared plus 2 times -1 plus 1. Clean this up a little bit. I get 1 minus 2 plus 1, which would be 0. So I know I have the point -1, 0. Hope this helps. Please complete the homework for 4.9 and make it a great day.